Hello, welcome to the first tutorial. I'm going to teach you some basics about UndertaleModTool and how to use it. Now, first, obviously, if you want to get started, you're going to need to download UndertaleModTool, and the actual name UndertaleModTool is a little bit of a misnomer. It's not actually exclusive to Undertale at all. This will work with, as it says here, other GameMaker Studio games. It also supports GameMaker Studio 2. This even includes the 2.3 beta that they've recently been developing. So you can play, or edit rather, a lot of the newer games that have been coming out. Now, it's not perfect with these newer titles, but we'll get to that later. Now, to download it, more likely than not, you're going to want to be grabbing it from the releases here, which is just on the side of the GitHub page. I'll put the link to here in the description. And from releases, you see you'll want to go to the latest version, which will be at the top. It's got this little green sticker that says latest. And there are two downloads here. You don't want the source code unless you're actually going to be modifying the tool itself. More likely than not, you're going to want the UndertaleModTool-net bundled file, because this includes a lot of libraries that are not going to be on your computer by default. If you have Visual Studio installed, you will have these libraries though, so you can just download this smaller one underneath, which has about 50 megabytes, smaller 60 megabytes. And once you get that, all you have to do is open this. You'll want to unzip this somewhere on your computer, but I'll just show you this .exe file right here is what starts it. And you'll get this window here. I'll close that for now. And if you want to start playing with some of the more recent releases, you just go to this section called Actions. You'll click the one here at the top. That'll be different depending on when you come here. And if you scroll to the bottom, you see this section called Artifacts, which will have 3 downloads for the test builds of this newest version. These are generated automatically every time the GitHub updates. And more likely than not, you're going to want WinX64, which is going to be for your 64-bit 86 architecture CPUs, but depending on your CPU, you might also need WinARM or Win_x86, which is just a 32-bit version. And that covers basically downloads. So once you get that on your computer, when you start it up, it's going to look a bit like this, which is, it's not a very flashy UI. It's very basic, but it does its job. And however, you'll notice that there's kind of nothing here. There's all these categories, but if I click on, say, Sprites, it doesn't actually do anything. It just says here, load data.win file first. So included with every GameMaker Studio game, or almost every GameMaker Studio game, there are exceptions, it's complicated. You'll have what's called a data.win file. So if I go here to Deltarune, which is the game I'll be using to test here, or to show off rather, you can see this file called data.win. You also see when it shows up this file called audiogroup1.dat. UndertaleModTool can actually open audio group files as well. We won't talk about that right now, but we'll just open up the data.win, and I can just show you what it looks like. It'll give us this little warning, because the Deltarune Chapter 2 version was actually made in GameMaker 2.3, which is the current beta. It says that this game was built using GameMaker Studio 2.3 or above, and that support for this version is a work in progress. So currently, if you try to mess around with the code for these newer games, it will struggle quite a bit. UndertaleModTool needs a lot of work in the decompile and recompiler compartments, so you'll likely run into some issues if you try to do that. It's going to work a fair bit of the time if you're editing code, but there are some specific things, like the functions in the new version will throw it off quite a bit, as well as some other more niche aspects, and you may also have what appears to be from the mod tool successes, but which will actually not work when you launch the game. There's a lot of work being done there, but I won't get into it now. Now, we see that there's all these arrows next to our different types of data, our different asset types. We have stuff like sounds, sprites, scripts, game objects, rooms, and code, and whatnot. These are all of the different assets that are actually in a game that you make with GameMaker. Some of these are going to be showing up if you're in the GameMaker Studio editor, but some of these, like code locals and variables and embedded audio and stuff, these aren't actually in the GameMaker Studio. You won't see it in the UI at least, but these are sort of the underlying data types that everything else is built upon. Now, stuff like in this lower section, these underlying data types, you want to avoid dealing with those whenever possible because it's either A, unnecessary, B, a huge chore, or C, both. And you just don't want to touch those if you can help it. I'll give you a little bit of insight on how these work, but again, it's best to avoid them when possible. Now, at the upper section, we see some stuff. There's also some stuff you don't need to deal with. General info and global init are not usually important. But stuff like sprites, game objects rooms, stuff like that are going to be very, very useful. You're going to be editing those a lot if you want to use this tool to make your own mod. And I'll just kind of show off some basics of that. We'll start with rooms, since rooms are kind of the most fundamental. We'll take room beach, for example. And now there's kind of a lot on screen right now. I'll go by it bit by bit. At the bottom here, we have a little preview. This is kind of what the room looks like, but it's really more, it's a closer approximation of what the view would look like if you're actually editing a room in GameMaker Studio. It's not quite the same. For a start, usually if you're examining, you will see some little inaccuracies, especially in the size and position of game objects. So don't rely on this preview too heavily. If we want, we can save this as a PNG and it will just save us an image of what this room looks like. Don't worry about that too much. It's not too important that you do that. Now, if we're just on the base room object, this has a little bit of data associated with it. We can see how big the room is in pixels. It's our size. What the room is named. What the background color is, and whether we should be drawing it if we have any spare space. And some other information. This stuff you don't usually need to edit. That's usually not important. You also have creation code, which is just a piece of code. Now I can just drag anything from the code section in there, and it will run that as creation code. Although you should be making your own code if you want to do that. Creation code just runs every time the room is created. And you see also views. Views are basically just what the player actually gets shown on their screen. The size here is sort of how big the view is in terms of the pixels of the room. And the port size is how big it gets displayed, actually. So you can see it's a bit bigger in the port size. You also see this border. That's, again, these things aren't too important, but it's just important to understand them. Enable tells us whether this will actually be outputting to something, to the screen rather. And follow the object just kind of indicates that it will be centered around our main character, who is starting here. And yeah, we'll move on to layers next. Layers, there's several different types of layers. Like if I click on this one, we could see that this is an instances layer. And layers themselves have a little bit of data. The most important things you're going to want to see here are the layer ID. Every layer needs a unique ID. The ID has to be unique, not just for the room, but for the entire game. So you can't duplicate this, or you will start to run into problems. The depth is another important thing. This is probably the most important piece of data for layers. Depth actually determines the draw order of layers. So the first layer to draw will be this one called compatibility color, because as you can see, its depth is very, very, very big. This is a different type of layer. This is a background layer. This is just going to draw literally the color black underneath everything, and just in case we can end up seeing that underneath. But at the top layer here, we have a depth of 0, which means it will be the last one to draw, and thus it will, when the game is drawing this room, everything in layer 0 will be drawn on top of everything else. And so this is generally where you'll see the most important objects, things like our main character here. Apologies, that was taking me to the game object definition. The main character here. Instances in an instance layer also have an ID. This also has to be unique throughout the whole game. No two instances can share the same ID. Usually you'll see them just being assigned in order. Like here we have 100,335, 336, 7, 8, 9, so on. As long as it's unique, nothing else really matters. Instances also can have their own creation code attached, as well as the room itself. And they also receive a scale, which determines how much to scale the object up by. So right now it's just X scale of 1 and Y scale of 1, so it will be drawn normal size. And there's also a rotation, which is in degrees. So if I rotate this 90, the character will rotate 90 degrees counterclockwise, and so on and so forth. There's also pre-create code. This isn't usually too important. This is just create code, but it runs first. And that's basically what you need to see about rooms. Now, if I want to start creating things that I can put in a room, you'll want to be messing with game objects quite a bit. So for example, if I open up this one called Object Face, I'm just picking this at random. Okay, this one doesn't have a sprite. I'm going to pick something else. NPC Butler, whatever. This is just a swatch line right here. We can see there's a bit of data here. Most of this, again, we can ignore. Everything in this section, usually you won't really need to touch, especially not physics. Physics aren't really important at all. What's important is the object's name, which we have up top. We have a sprite called SPR_NPC_swatchling_down, which is what sprite it's going to display. You can actually change this at runtime, but this is just the sprite that it will start with by default. And we'll have, this is the most important part for editing game objects, we'll have the code that's associated with this game object. Code that associates to game objects are called events, and we have several different types of events. The most important types are going to be your create event, your step event, and your draw event. Create runs once when the object is created. This runs after creation code and for the room and for the game object instance. This is going to be running after that, but before everything else. This is usually where you'll see things getting set up, stuff like the just some variables, and usually maybe an image scale like we have here. And you'll often see event inherited if it's if this is inheriting it from a different game object. So game object can actually have a parent game object, and they can inherit certain behavior and characteristics from this parent object. So this is actually a really useful tool for developers making their games. So this is actually something you're going to find quite often. And in this case, it's just inheriting from a overlying NPC class that represents how NPCs move around in rooms. Pretty straightforward. You'll also see every object has this pre-create code entry, but it basically does nothing. You never need to look at that. It's basically never used. It's just there because that's what's going on inside of the engine. That's how the data is actually stored. And next you have the step function. This is another very important function. This function runs every single frame, and this is going to determine how the object behaves. So we can see here that it really just controls some minor stuff like changing its color and changing what sprite it has. So, and this is what code looks like in UndertaleModTool. It's very close to the original GameMaker coding system. However, this is actually not how the code is stored internally. This is actually what the code looks like when we decompile it and turn it back into GameMaker. If you remember that pop-up we got when we started opening this file, that this isn't actually fully functional yet. So in this particular case, it's working just fine, but it sometimes might not. And if that's the case, you're going to want to start trying to edit the assembly. This is quite difficult, but I'm not going to go over assembly editing because I don't really know a lot of x86 assembly, but that's what you would do if you couldn't edit the GML. If you can, though, you could just change whatever you want in this. So I could just change this, I could say number to 10. And if I click off of that, it will actually, you see it saves that, and it will modify the assembly to match. But that's code, that's a step event, so which run every frame. The other event that runs every frame is draw. It actually runs after the step event, and this is just what draws the sprite. If there is no draw event defined, it will just draw the sprite based on whatever frame rate it's provided, whatever sprite you give it to start, and it will just do that automatically. You see a few other types of events here. Collisions, very, very important. Collisions define specific behavior that occurs when this object collides with another object. So if I were to add a collision event, you have a unique events for every object it can collide with. I would have to drag the object over like that. That's how you usually give it data that is from another object. So I can now add a code entry that would run whenever I collide with this particular type of object. I'm just filling in random things. It's not very... I'm not trying to actually do anything right now. I'm just kind of showing how things work in the tool. You also have some methods for querying player input, like keyboard, mouse, key press, key release, etc. Another important data type is alarm. Alarms can be called from other code and will execute after a short delay that has been given to it. So many objects will have alarms, and you'll see them called from a different piece of code. And that's more or less all you need to know about these different event types. And next we'll look at, just real quickly, we'll look at sprites. So if you see a sprite, there's actually multiple different pieces of data here. First we have the name, then we have the size. That's just how many pixels it is in width and in height. Then we have the margins, which this is usually what they'll look like. They'll just go from the top left to the bottom right. So left and top are both 0, and right and bottom are just the size -1. We also have some little checkboxes here that will draw this sprite either transparent or smooth. Preload determines whether it's loaded ahead of time. You usually don't need to play with these 3 boxes. They're not too important. We also have a bounding box mode and some stuff about masks. Again, not important. Origin determines sort of where it draws the sprite from. So in this case, it's 0, 0, which means that if I have some piece of code, I don't know, we'll just open some code right now. So if I have draw sprite, and we'll say SPR plate. So if I give that a position, let's say 1924 or something like that. This isn't terribly important. I'm just demonstrating what this looks like. So I just give it this position. 1924 is the position where it will draw the origin of our sprite. So if we go back to that sprite, hold on, I slightly lost my place. So 1924, since the origin is 0, 0, is where it will draw the top left of this sprite. If we move the origin somewhere else, that is where that's just where we define the sort of central point of the sprite as where it actually shows up when we draw it. And the collision mask is going to be determining essentially when the sprite gets counted as colliding with another game object, when it's attached to a game object, of course. And here we can see this one is just all white. It's just a white square. And the collision masks are actually binary data, so you'll see 2 colors, black and white. The black determines, black is sort of empty space, so if a black segment of the collision mask is colliding with something, then the object is not colliding. But if it's all white like this, that means that anything in this entire rectangle for the sprite is going to count as solid. And that means it will collide the moment it overlaps with another one. Now, if I want to actually look at either of these, I can just do, for sprite, there's export all frames. That gives us the different frames of the sprite. So if I export that and I go to the folder I exported to, we can just see it will just look like this. I can open it up in paint.net, which is what I'm using here. I recommend that if you're going to be modifying sprites. And you can do the same with masks. Although it requires a name with mask. For some reason, it doesn't automatically fill that in. And like I said, it was just a white rectangle. Nothing interesting to see here. Playback speed here, if it's a multi-frame object, if this object were to have a whole bunch of textures, like let's say we can add, I don't know, we would be able to add other texture page items here. And playback speed determines how often it cycles between these. You'll see some cases where this gets edited in code, but this is just the default value that it uses. And this can be either as frames per second or the number of frames per game frame. So 1 game per frame per game frame rather. It means that every time the game ticks, the sprite will update. And version and special type, you don't need to think about these. You shouldn't be changing these. By default, for GameMaker Studio 2 games, this is going to be just 3 for the version, and it'll be ticked for special type, always for every sprite. This only really matters if you're modding GMS1 games or something very, very old like that. Now I'm going to show you just very quickly what backgrounds look like. Backgrounds are very, very simple as well. Backgrounds, you just link them to a texture page item, which is going to basically decide what gets actually drawn. And you'll also see some data here which defines the tile set. It's really not too important that you know exactly what this is doing, but it just tells it how big the tiles are, how many tiles there are, where the tiles are, and what IDs it should assign them. Nothing too fancy. Paths, they're very, very simple. They just define sort of a sequence of points that an object can follow. And right here we see the positions and how fast the object will move along them. Again, not very, very important. These don't get used a whole lot. I just wanted to show you that they were there. Fonts, you can also change. Now you can see that's a very large amount of data. This actually defines data for all of the different characters the font supports. So the number here is actually the ASCII value of the given character. So if I were to look up an ASCII table, I would probably be able to tell you what these corresponded to, but I don't have that off the top of my head, and I did not open one. Fonts are also associated with a texture, so this font will actually be drawing directly from this image we have here. And it doesn't actually use any of your system's font files by default. It will actually just package this up as an image so that it works cross-platform. Range just defines sort of what characters it's allowed to draw, and it will presumably throw an error if you try to draw something that isn't in the font. Last thing I'm going to sort of show off in my tour, I'm going to kind of show you a little bit about strings. Strings aren't so important, but you should probably know how they work. So you can see here, if we just go to strings, I just see a whole bunch of junk. This just represents every possible string that the game has, and we won't actually be editing strings directly. But if I were to make, say, a new object, we'll make a code entry for now. And if I wanted to rename this, which I will, it's pretty important that you do this. Let me just check what scripts are formatted as. So it's GML, script, uppercase, SCR, my script. And if I change that and if I click off it, which is how you kind of register that you've finished changing something, this little pop-up will come up. It'll say string reference changed. You edited a string reference. What do you want to do? Now, if you're making a new string like I was, most of the time you'll want to click change all occurrences of this value. That's almost always what you're going to want to click. And that's important because it'll generate a new entry in the strings section. So if I search now, we can see that this is now here when it previously was not. Actually, I will also talk a little bit about sounds, just to kind of show you what's going on here. Sounds have a few basic parameters. We have the name, we have a file name. Now, these file names may not necessarily be on your computer. They may or they may not. It depends. We have some flags that determine like where the sound is, because sounds can be in essentially 3 places. If I go back to the Deltarune folder, sounds can be, we can see we have a lot of like just random OGG files that are just hanging around. Let's see, is Mercy Add one of them? No, it actually isn't. Assuming Windows search is not betrayed my trust. So, like I said, this file name doesn't necessarily correspond to there being a file on your computer, but sounds can be just stored as files like this individually. You can have them stored directly in the data.win, or in some cases, you can have your own external audio group files, which is where some sounds are stored. So if I find a sound that's stored there, this one you can see it's not in the default audio group, it's in this second one called audio group _SFX. So if I actually go to the audio file, it will actually open up, we see at the top audio group 1.dat, because this isn't actually in the data.win file. This is stored in an audio group instead, which is a separate file, and it's complicated exactly how it works, but that's basically just, it can store in a lot of different places. And there's obviously this little button that says play, which will play the sound effect, and stop if you want to stop it from playing. We have some things like effects. You don't really need to think about that too hard. We have a volume, which is multiplier. Multiplier of 1 plays it at normal volume. 2 we play it at double volume. If I want to mute the sound, I just set it to 0, like that. We also have a pitch, which would pitch it up or down, depending. The default value for that is 0. We have an audio group, like we mentioned, which you can find. There are only 2 in Deltarune. These are kind of a bit like texture groups in that you don't want to deal with them directly. But you do need to understand how they work if you want to be effective in using UndertaleModTool. Pardon me, UndertaleModTool. I kind of garbled that a little bit. And you'll also see they're associated with this. This is true of all, both external and internal sprites. They're associated with this embedded sound. The only thing this isn't true for is when they're just individual files. You won't have one of these for that case. And this is what stores the actual sound data. The sound itself only stores the parameters we see here. It's just a bunch of references and the name, of course. So this is where you actually have the sound data. And if I want to change what the sound sounds like, if I want to add my own sound, I would have to click import. And then let's say, I don't know, grab some sounds. I would just, if I wanted to change the sound, I could click import and import a sound. And it would just import that sound, and that would be the new sound. And I could similarly export sounds. And that would actually save the sound file to the place that I saved it to. And I could play that in VLC if I really, really wanted to, but I don't. And we could also play it directly from the directly from the embedded audio. Yeah, nothing too interesting here, but that's just something that you should understand. I'll cover all of this in more detail later, but that's just giving you a basic overview of what the tool looks like and how it works. Last thing I want to note is that obviously I've got to tell you this. Piracy is a crime. Don't distribute the data.win file for these games. It can get you in big trouble. It's not a good idea. You do not want to do that. I'll tell you how you can give your mods out without doing that. In a future video, I've made a whole tool just to do that. And that'll be coming up very, very soon. But just don't do that. It's against the law. It's copyright infringement, this, that, the other. It's not a good thing to do. You shouldn't do it. Because obviously you can get charged hundreds of thousands of dollars for distributing copyrighted content without the author's permission. You can go to jail even. It's an international crime. I'm sure they have a way to find you. I wouldn't know what it is. Just don't do it. Alright, I think I'm going to call it here. I'm about done with my tutorial. I'll make some more in the future on some of the intricacies, some tools you can use to make your job easier, some of the scripts that get included, and some other functionality in future videos. But for now, I'm going to call it here. Have a wonderful day, and thank you for watching. Leave a like and subscribe if this video helped you.